Hello everybody, this is going to be a quick explanation video on how threshold slices is supposed to work for the Kamer lab, specifically how it's supposed to slice up the offset range and not the total array itself. So I'm not sure exactly how you got here. Maybe you got here through some normal mechanism from the course, some slide or some link on the wiki. Or perhaps you got here because you failed this test, the slices threshold preliminary test, which has been added specifically for this video and for this example. In this case, it currently says like you seem to be attempting to slice the entire array when you should be slicing the offset range. And watch this video for further explanation. It's currently TBD. It will be updated in your repo shortly with the actual link to this video. So let's talk about the slides. So if we ask you to find all the 3mers in this array and n equals 10, imagine that scenario. So the first question here is like, how many 3mers are there if n equals 10? And so if everyone could pause the video and answer that question. All right, so hopefully most of you came up with the answer 8. If you're a little confused about that, the 8 3mers in this array are ACT, CTC, TCA, CAT, AT&T, TTA, TAC, and ACT. Okay, and you can think about it. There's 10 here. If you minus 3, that would bring you to 7. But there's one last one here that fits here, so that's n minus k plus 1. So that's the 8, okay? And I want you to imagine if you slice up the array this way. So imagine that someone says, all right, we're trying to figure out if these things are too big. Please slice up these sequences. This sequence is 10 long. And someone says, all right, if somebody passes in something that's like, greater than 5, you're going to split it up, right? And so you pass in the whole array, and like you do mid to mid, min to mid, and min to max. You make these 2 slices, and you go in, and then somebody starts Kamer counting this, and now they're doing the n minus k plus 1 thing. And so they count these 3, and this slice counts these 3. So what's wrong with this picture? And I'll pause the video, and all right, we're back. So hopefully a lot of you sort of picked up on the fact that this is 3 and that's 3, and 3 plus 3 is 6. And n minus k plus 1 is 8, right? And so rather critically, does 8 equal 6? No, it doesn't. So what happened here is these Kamers right here, CAT and AT&T, are lost, right? By approaching it this way, where we like sliced up the whole thing and then did the n minus k plus 1 trick on this sort of slices, we've lost these guys in the middle, right? And so you could try to write something that said, all right, well, am I the full range? Okay, if not, like go over the edge, and then don't go over the edge when you're in the end. And that's just kind of a hassle. So let's not do it that way. Let's find all the 3mers. But when we slice it, let's not slice from min to max for the whole array length. Let's just slice the offset range. And by that, I mean slice all of the initial offsets. And so that's array length n minus k plus 1 from 0 to n minus k plus 1. And then we can go ahead and do our min max slicing thing just like normal. What you end up with doing here is then when you build your actual Kamer counter, you'll just count from the initial offset from min to max of the slice, right? Now, this can be a little bit disconcerting, right? Like you're told to slice from min to, like this slice goes from 0 to 4. And you're gonna like do your last one for 3, you're gonna stretch out from 4 to 6, right? And that's a little disconcerting. This one is gonna be 8 up to, but not including 10, to 10, right? And so it feels a little disconcerting, but if you think about it, it works out just right. Everything's exactly how it should be. And this overlapping on this is doing the exact overlapping that Kamer counting wants in the first place. So hopefully this helps, and good luck on this lab.